Okay, the next step we're going to take is removing the existing thermostat housing cover, because a lot of this scaly buildup was soft, but as I got standing down closer to the bare metal, it got tougher and tougher. One of the folks who commented on a posting on Facebook suggested that is electrolysis that causes that. After 47 years, I would not want to disagree. It is very possible it's electrolysis that causes that buildup, whatever it is. It was more than I wanted to deal with, especially if Linda can get a close-up down here. There's a gap between the bypass hose port and the radiator hose outlet where it's really tight, and I couldn't get in there with sandpaper and properly descale that. So I did what any red-blooded American would do. I bought a new housing cover.
Beautiful.
This cover has a pipe plug in it we're going to be taking out, because in 1973 with the 302 engine, Ford was using vacuum ported and vacuum manifold vacuum thermal control switches. And the switch is over here. Now, earlier, I don't know the video, because I was messing around down here, I popped off this one vacuum advanced diaphragm hose. It goes back on easy enough, but it's too easy to take off. But this requires, in some situations, a special socket. In this case, I could have used an open-end wrench, but I have the socket, so I'm going to use it. So I'm going to remove the center port for the vacuum advanced diaphragm. The top hose, which has a yellow stripe on it from the factory, goes to the carburetor for what's called ported vacuum. I'll move it out of the way. The bottom hose goes to manifold vacuum and has a red stripe on it from the factory. Well, this is in an obscure area. There's a metal fuel line kind of in the way. But at least if I wanted to, I could get an open-end wrench on this thing and pop it off. In some automobile configurations, these thermal control switches for vacuum control are not where you can easily get to it with an open-end wrench, and a box-end wrench won't work because these port nipples are in the way. So there's a special tool. It is a vacuum switch socket. In this case, 1/2-inch drive, and it fits right on top. Okay, so the vacuum hoses are all removed. Yellow is ported, yellow stripe. Hard to see, maybe, there it is. It goes in the top of the switch. Distributor vacuum advanced goes to the center, and the manifold vacuum, which is the red stripe, goes to the bottom port. Now, on some engines, like this one, you can get a box end or an open-end wrench on that vacuum switch and remove it. Other engines, it's really hard to get to, and you can't use a box end wrench or socket, conventional socket wrench, because these vacuum nipples are in the way. So there's a special tool. It is a vacuum switch socket. It's made for Ford and GM and Chrysler. This one's a 1/2-inch drive, and this is designed to slip right on top of those things. Now, before I unthread that, I need to point out a few things. I'm taking this out now because doing it afterward might be difficult, because I have to hold this housing still while putting enough torque on this thing to remove it. It's been there for almost 50 years, 47 years. It's going to be tough. So I'm going to do it while the thermostat housing is installed in the engine still. Now, having said that, once I take the thermostat housing off, I put paper towel underneath it because there's going to be coolant that's going to spill out. I wanted to try to capture as much as possible with paper towel so there's less mess to clean up underneath the car. But there's still going to be some. So, here we go. Off with the vacuum thermal control switch. If this breaks, it can be replaced. They're still available. There's different kinds, 2-port, 3-port, different opening temperatures, etc., etc. This is all part of an emission control schema where at low coolant temperatures, like when an engine is stone cold, it will apply manifold vacuum to the advanced diaphragm and help the engine run better with the vacuum applied and advancing the ignition spark. When it warms up, this will send ported vacuum to the diaphragm, not manifold vacuum, so the vacuum advance only will activate an advanced ignition timing when the carburetor throttle is being opened up, not all the time, and is progressive in nature. And that keeps from having too much of an advanced spark that causes higher compression and combustion chamber pressures while the engine's running. That will create excessive nitrous oxide emissions, and that's why this thing is in here, to help control nitrous oxide emission. Who knows how well it worked? Anyway, here's what they look like. That's going to go in the new housing once we have the new housing in place. So now it's time to go ahead and remove the thermostat cover. After I find an appropriate size wrench. Now, the one bolt is easy to get to. I could use a socket wrench for that. The other bolt is down behind the water pump, and that is going to be a real pain in the tail to take off with the water pump in place. Now, luckily, I just kind of hung the water pump there with 2 bolts very loosely just to make sure everything lines up. I'm going to move it out of the way and see if perhaps it makes more sense for me to put a socket wrench on there and take all that apart. I believe it will. I haven't done these for a long time. I think it's a 1/2-inch hex bolt. I'm going to double check. Yes, it is. Because when I get the socket wrench on that thing, I don't want to have to swap it out once or twice. First of all, it would be embarrassing to do it on a video. Second of all, what the hell? I just want to make sure I get this as right as possible. Okay, so loosely suspended, and it is now off. Let me get that. Now, I'll just put it right down here and out of the way. So now the trick is to find a 1/2-inch socket. I've got sockets all over from the teardown. I found one. And find a ratchet handle. And find a 3/8 inch long extension. If I have you move those and see if it's up there, because I know I pulled one. Who knows where it went? Better yet, I got something even better. From the teardown, there's a deep well socket on the electric impact that I think is a 1/2 inch. And yes, it is. So I can put that right down here. Boy, that's a noisy thing. It does not want to come apart. And it didn't. Okay, I might have to get a box wrench on that one. This ought to be easier. Now, for anyone thinking I shouldn't be using a conventional socket and an impact wrench, you're right. Technically, I shouldn't, but I'm doing it because I don't have 3/8 impact sockets because I rarely use this. It's a new toy. All right, I'll try this once again.
You're at an angle.
Yeah.
I see the angle.
Okay, box wrench.
Okay, I'm going to stop this because I need to go get a battery charger.
Okay. Okay, today I'm hoping this time for sure to install the water pump, the new water pump, now that we have the thermostat housing cover piece on. I found a combination, or excuse me, a box end wrench with a nice offset to it. I could fit on that lower bolt that the other day was so hard to get to, and confirmed that it is nicely torqued down nice and tight. So that's not going anywhere. We should not get any leaks. So in preparation for what we're about to do, the water pump needs a gasket. Actually, there's 2 gaskets, but one is already installed by the manufacturer of this water pump. This pump has a backing plate. Manufacturers already put a gasket in between that water pump and the backing plate and bolted it down. I'm going to leave that alone. Now, the gasket that came with the water pump is probably a fine gasket, but I happen to like Felpro brand gaskets. They've been around for many decades. They always seem to do a great job. And so once I have this thing flipped over like it needs to be, to where it's going to work properly, there we go. What I'm going to do is point out the 2 places we need to goop this thing up with gasket sealer. The only places that need to get gasket sealer are around this water outlet and inlet. And the reason for that is because everything else backs up to the timing case cover with nothing but empty air in between. In fact, at the bottom of the timing case cover, you may or may not be able to see, there's a small little groove cut. That is a little air vent. And that is there for 2 reasons. First, so that there isn't pressure or vacuum behind there as warm air and cool air from the engine heating up and cooling off causes pressure with a sealed surface if someone did seal it up. And second, if there is a leak in these areas here, it's got somewhere to drain out of so someone can see that, hey, we got a leak. But anyway, there's no need to goop up the whole gasket. It just would make it hard for someone to take this off of the timing case cover in the future, 47 years down the road, when this water pump has to be replaced. So after I have it gooped up, I'm going to set these in place, and I'm going to go ahead and get some water pump bolts, at least 1, maybe 2, run them through, lightly thread them in place, and then I'll start setting the other bolts in position as the 2 main bolts are holding this in place. And after I determine which bolts go in which hole, I will then go ahead and start taking the bolts out. The ones that are going into the timing case cover, I'm going to put anti-seize on it, and the ones that go deeper, pass through the hole in the timing case cover and actually bolts into the cylinder block itself, often into a water jacket. I'm going to put gasket sealer on it, so the bolts that do go in the cooling chamber won't leak.
Do you know, can I interrupt you? Do you know which of these are those, you don't know which are which bolts, but you explained that some need some anti-seize and other stuff on here. Do you know which ones are which?
Yes, I'll be able to tell.
Okay.
Typically, it's the long bolts that go all the way into the cast iron engine block.
Okay.
The others are all tightening into the timing case cover, which is aluminum, and I don't want to have problems with those bolts getting seized up over time.
Okay.
So now I got to find a way to balance this water pump so I don't have to be holding on to it. That's going to be a trick. I want it to be solid and stable without falling. There, I did it. Almost. Maybe. Maybe not. Okay. Now, bolts. With this thermostat housing cover, previous video, I took the time to clean off the threads of the bolts that were going to be holding it in place. These water pump bolts, I'm not going to do that. Not because they don't need it, but because I decided to replace them with new bolts. It's overkill. I know that. These bolts are all different sizes. This is a kit that is made for different variations of the Ford 302 engine, so it has more bolts in it than I need, but they have the right length to them where I need them to be. So I don't see any sense of running those through a die to clean the threads up. They're already clean. They're new. So I'm going to have Linda go ahead and suspend the video recording as I pull these bolts out of the package and get them lined up. And then I'll have her start again and we'll start putting the pump into place. Okay, in order to prep this, I'm going to go ahead and put gasket sealer both sides of the gasket like I had mentioned a few minutes ago in this video, focusing on those areas around the inlet and outlet of the water pump. I'm not worried about much of anything else. I might go ahead and put some sealer around where each of these bolt holes is at in case there is any coolant seepage for any reason that might come through. In other areas, I doubt it's going to happen, but it's just more to hold the gasket in place as I put this assembly up. So it'll make more sense in a few moments what I just said, I hope. Like I did yesterday with the thermostat housing cover, I'm going to put the sealer on one side of the gasket, rub my forefinger and thumb together, just smear it around, and use the excess on the other side. It's always worked out nicely for me to do that in the past. We don't need a lot of it on here. Even though I'm going to be sharing it with both sides of the gasket, it just takes a thin coating.
You can use that to get on the other side.
Yeah. If I run low on gasket sealer, as I'm gooping up the other side, I can always add more. boring. I feel like I should be saying something while I'm doing this, but it's such a simple thing to do. It's not much I have to really say.
Talk about the great glove invention we created there for you.
Oh yeah, Linda, she cut the rest of the glove that's too small for me, so it fits on my thumb and forefinger perfectly for this task. I thought that was pretty clever of her to suggest and then do. She's far more than just a pretty face behind the camera. She's been awesome to chat with and to enjoy spending time with. These bolts go into the timing case cover, not anywhere around any kind of coolant, so I'm not going to bother gooping that up.
All three of those?
Yeah.
Oh, that third
The
one.
one doesn't have a hole.
No hole on it.
This gasket is made for different flavors of these water pumps. Sometimes there's a hole through there, sometimes there's not, depending upon the model and year. Can I have you hold this so it doesn't fall?
Mm-hmm.
Just keep it stable. Thank you. Okay, so now I started gooping up the other side, sharing the sealer as evenly as I can and without getting too much sealer. I have found where it is possible to get too much sealer on a gasket, it squishes out, it's a waste, pain in the butt to clean up later. So I'd almost rather have too little than too much, at least looking that way. We just need to be tacky. And as consistent as possible around the areas that I'm trying to get sealed. And of course I just slop some on my forearm from this side. That's okay. No big deal. This is a very forgiving part of the task.
I'm going to take a picture of the actual sealant here.
There's a lot of good gasket sealers on the market. I happen to like Permatex brand. They've always done right by me. I've never had a problem with their different sealers. And this one is made specifically for water pumps and thermostat covers. Even says so in the label. Okay, I don't know if it's possible for Linda to zoom in or show more closely the two areas on this side and on the flip side.
Okay, what's the side that's going to go down?
I don't know yet. I'm going to figure that out in a moment.
Okay.
It depends.
That way.
Not that way.
Yeah, it was that one.
No. This way.
Oh.
I'm going to press this into place gently. Now this gasket didn't have to be straightened out because it shipped pretty flat. So I didn't have to bend it to make sure that it wasn't at such a bend that it wouldn't stick on here properly.
The one that came with it was...
It was slightly bent. I would have had to straighten it out just to make it easier to install. Probably wouldn't make a difference functionally once I had it put together, but I just like things to go easier than not. Not mad being lazy, I don't think. Just matter of trying to be reasonable. Okay, so my little gasket seal I got on my fingers, I'm going to go ahead and try to get rid of just because I'm that way. Now comes the fun part. Putting it in place partially or gently so I can go and start prepping the bolts one at a time to put into place permanently.
That doesn't look centered.
Oh, it'll center up in a moment.
Okay.
So what I'm going to do is I'm going to try to determine which bolts I'm going to put in place to hold this thing up and suspend it. And I think I have a few in mind. to find out. I'm going to start with these. The bolts I'm going to use are going to be too long for the job. That is intentional, because all I want to do is have something where I can slide this pump back in place and move it around a little bit. As I start running, there are the bolts down. Trying to get my footing is going to be difficult because of how our 4-post lift is located in the garage. I don't really have good footing where I need to be. And this water pump is not necessarily heavy, it just feels that way when it's being picked up, the way I'm picking it up. Okay.
Just lifted it. Another set of hands or?
I think I'll be okay. I'm trying not to get too many hands involved, because if it does slip, I don't want anyone to feel badly. Like, okay, who let go of that thing? Probably would have been me anyway. Okay, that's going to help hold the gasket in place as I position the water pump. Or attempt to position the water pump.
Came off.
Okay, I need to give credit where credit is due. If you take a look at the water pump, I have it suspended by 2 bolts that are slightly in there just as a guide as I do the rest of the bolts. I tried several times to get that to line up, didn't do it. Linda came over and she went ahead and showed me how to do it. So not only is she a pretty face behind the video camera and a great companion and good with her questions, but she's also very helpful when it comes to doing things that I find difficult. So now what we're going to do, one at a time, try to figure out where these different bolts go. This one I determined is a long one that goes into the water jacket. So this is one I can use gasket sealer on the threads. So it will act as both a lubricant as well as a sealant. So if there is otherwise coolant coming out of there getting past the bolt head, this will help slow it down a bit. So I'm going to just slightly finger tighten that. I don't want anything ultra tight right now because it makes no sense to make things real tight. I'm going to go around the whole water pump perimeter, do the same thing, prep the bolts, put them in. If I don't use gasket sealer, I'll be using anti-seize where some of these bolts go in the timing case cover. Do one or the other. No mysteries here. We'll be back. Okay, the water pump mounting bolts are all in place, but they are relatively loose. I did that for a reason. This is the cooling system bypass hose. It goes, let me get this out of the way, in here. Looks like a pretty tight fit, huh? I've left the water pump loose so I can move it back and forth a little bit as I get this jostled in place, but this is what's called cut to fit. I got to cut some of this end off, some of that end to make it fit. The other thing I have to make sure of, have the right end. This end is too big for that, but it's the right size for here. These are different sizes. Some of these bypass hoses don't have a properly fitting for both ends hose. Nothing more than a heater hose is bent that someone has to struggle to get this on. Extra tight. And this is a little bit loose. I have to clamp it down real hard and hope that there's a leak. Well, that's not what I'm going to do. So I'm going to take a look and see where I need to cut this to make it fit as well as possible. So that's the one end. If I cut wrong, I have two more of these things. I bought an extra one because I didn't like how the two ends diameter was fitting. And the other one I just kind of got because I forgot I got an extra one before. No big. So this, I just have to take off a little tiny bit. Looks like about a 1/4 wrench. I can always take off more. I'd rather do that than take off too much. These are hard to glue back in place and keep it from leaking. That's going to fit. Now, I'm going to hunt for the radiator hoses I put for these things somewhere.
Are they big things?
Little radiator hoses. It might be up on the bench, might be up on the fender. I put them somewhere safe where I
Okay,
wouldn't
there's this
misplace
thing
them.
right here. Are there two of them or one?
Oh, here they are. I found them.
These aren't them? Oh,
No,
I got
that's-
you, those things.
This is the other one that would have fit properly. It has a slightly bigger end at one end. The other, I bought this as a backup in case I miscut.
Gotcha.
Now, in this particular case, this hose fits pretty well, sliding on and off pretty easily, because the other day I sprayed some silicone spray in here to help lubricate it, to make it easy. Silicone makes it easy to go on, also easy to come off. So when these get tightened down, they have to be tightened down correctly and tight, otherwise we have a problem. So I put these in place before I do anything else. I line them up so I have access to them, easy access to them. Once they're in place, I'm going to put the big end on first, just because, nothing magic.
Just me dropping things.
That's just a Teflon tape. We don't need it yet. We probably won't need it again. Hopefully not.
Just put a little end on.
So, well, I'll try one, then I'll try the other. So this is why I kept the water pump a little bit loose, so it can move around a little tiny bit as I try to get these into place. Look at that, still too long.
Well,
Okay.
that's not down all the way.
Oh, Linda's right, I didn't seat it correctly. There we go.
Perfect fit.
Can't get much better than that. Okay, before I tighten those up, I'll tighten down the water pump. I'm not going to bore anybody with all that. I'll have Linda suspend the video and we'll pick it up. So what I did off camera, I loosened, as you saw in the previous clip, the water pump mounting bolt so I could get this in place. Once it was in place, I tightened these all down and then tightened these hose clamps up so that they're secure. To reiterate something I said in a previous video, anytime you do any work taking off a water pump, always replace this. You do not want to replace this with the water pump bolted in place. It's easy to get out if you cut it up, but really hard to put back in. It was tough enough for me with the water pump loose. So what I'm going to do next is put the heater hose back in the water pump here. And once it's in place, I'll tighten that down.
Now that's the same clamp you're using. That's okay?
Yeah, this is the old clamp. These are heater hoses under the same pressure as a radiator hose, but they have a lot less surface area inside, so they don't end up swelling and rupturing. They tend to last a lot longer. I did buy new heater hose. I figured if I take a look at the condition of them, if they look like they needed to be replaced, I replace them. They look pretty darn good. I'm going to leave it. That's nice and tight without being over tight. Now, earlier, maybe off camera, Linda asked about this vacuum switch. Where is it? It's up on the bench.
Do you need it?
That, and as well as the Teflon tape that somebody dropped underneath the car.
Okay. Here's this.
Okay. Thank you.
And then I'm going to stop this to go
Yep.
get Teflon tape. I
Yep.
see it.
Okay, Teflon tape is going to be put around the threads of this switch to lubricate those threads. Just happens to do a pretty good job sealing coolant, gasoline, other stuff, but that's not what it's designed to do. It's designed to lubricate. Thank you. Oh, let's introduce Aaliyah. Linda,
Hi, Aaliyah.
Hello.
tell folks who she is.
Notice her shirt. She's a Mustang girl. She's our neighbor, and she helps often with anything project-wise. What are we looking for?
This goes into the thermostat housing. I guess tightens in. I'm going to go in finger tight, and then I have a special socket.
Does it look straight? No, thread straight. That's better.
And the special socket is designed to fit over this thing where it misses these outlet ports.
You had it. Where is it?
Right here.
Oh,
Get a close-up of that socket.
got it.
So that fits perfectly.
Do you want me to reach?
Nope, I'm good, but thank you. I want this in tight without being...
Hold it. Stop. It's grabbing a wire or something here.
Oh, thank you. Yes, that's the primary ignition pigtail. We don't want that having problems. Did you get it off?
Yeah. Okay.
Okay, I'm clear. We don't want this overly tight because it could end up cracking the housing. And you all saw what a pain in the butt that was to get off and back on. Looks easy, but it's not. Now there's 3 vacuum hoses that go to this. The first one has a red stripe. Can you get that?
Yep.
That goes to manifold vacuum. It goes to the bottom port. The other one has a
Yellow.
green or yellow stripe. That's ported vacuum goes to the carburetor. It goes to the top. The other one goes to the vacuum advanced diaphragm. It goes to the center. Now this is a good time to test the vacuum advanced diaphragm, make sure it's not leaking. I did this the other day. It was good. But they fail, and when they fail, it causes low-end performance problems, hesitation on acceleration. The engine is running in a perpetually retarded ignition timing state, works harder than it has to, engine runs hot.
Okay.
So, and poor fuel economy.
Nobody wants to drive their Mustang like that.
No.
I have in my hands a vacuum test unit. It has a rubber hose. I'm going to put back over the vacuum advanced diaphragm inlet, and then I'm going to start pulling on this knob. If you look at that gauge right now, it says 0 inches of mercury, 0 vacuum. I'm going to pull, and now you see it moved. It should sit there and not move until I release vacuum. If it is leaking, it will either gradually drift down or it won't hold vacuum at all, and you know you have to replace that. Some folks replace the entire distributor. Can if you want. May not be a bad idea if it's an old distributor with a lot of miles, but if you want to go inexpensive, these can be purchased separately. The only thing to be aware of is inside the distributor there's a small E-clip. If you take it off or put it back on without being careful, it'll drop down inside the distributor housing. Then you gotta pull out the distributor and find it. Otherwise, it'll chew things up.